Hello, let's think of a situation where if I have two lines, let's say that goes through the origin right here, and this is the x-axis, this is the y-axis, and we're going to let this angle right here between the x-axis and this line be the angle beta, and we're going to let this angle right here between this line and the x-axis be alpha, right? Then we could see that the angle between line 1 and line 2, theta, right, is going to be, we're going to make it the absolute value of the difference between those two, right? And the reason we have to do the absolute value between those two is because what if and this would be a negative angle, you could see you'd end up adding it. But if you imagine if line 2 would have went right through here, the difference between them, we'd have to find the difference between them two if they're in here. So if you could see that, right? And that's the angle between them, right? Now, if this is line 1, this is this situation, right, would be it's going through the origin, so it's the equation of that line would have some slope 1 of x, direct variation going through it right here, but the slope would be 1. And this line, if we would be a different line with slope 2 of x, and then we can see, well, how can, if we think of the vector that's in this line somewhere, some vector in this line, right, what we know that the tangent of beta, right, the tangent of beta would be equal to what the slope is, right? So that would be slope 1, and then for this one, similarly, for this one, the tangent of alpha would be equal to m2, right? And then beta would be tan inverse of slope of 1, and alpha would be equal to tan inverse of slope of 2. And then we can use the vectors to find out what these slopes are. I ran off the page here for you guys. Sorry about that. I'll move over right here. So this is what I have. The tan of beta is slope of 1 of the first line, and the tan of alpha is slope 2, and then we can solve. And then if we have these vectors, we can use these equations, right? Use this equation to help us find, the angle between them. It's just an alternate way. We could use a dot product, and that's more practical, but sometimes we do use this method here. So it says, in the plane given two lines with gradients m and 2, so the slopes 1 and 2, we can calculate the angle between them using the formula. The theta, the angle between the two vectors or the two lines, is the absolute value of the difference of the two, and where alpha is arctan of the first of m1, and beta is the arctan of the second slope of the other line. Good. So here, let's go ahead and you use this an example. Well, we'll use both methods, but we'll use originally what we've done. So here's example 41, and it says find the angle between r equals r is this is the vector equation of a line, so it's r1 2 and some scalar times the vector 2 3, and then just here is in Cartesian form. So the vector in this line right here, u, would be equal to 2 3, right? And if I want to find the vector that's in here, the slope of this is it's rise over run, right? So this would be the vector 1 2. And if I use the method that we've used before, the cosine inverse of the absolute value of the dot product, so that would be 2 plus 6, right, over the magnitude of this guy would be 4 plus 9, that's 13, root 13, times, and this would be 4, that would be root 5, right? And then I can go ahead and use my calculator, and I can say the cosine inverse of, let's say, the absolute value of the fraction. It looks like 8. No, I didn't put the fraction in there. So 8 over, let's say, root, it's going to be 13 times 5, right? And that comes out to theta is equal to approximately 7.12 degrees. Good? But we can also use what we used before, right? And we can say that our theta is going to be absolute value of beta minus alpha, right? Good. Where beta is going to be the tan inverse of the slope, right? And this would be the rise over 1, so this is 3/2, would be the 3/2, and then alpha would be the tan inverse of the slope, which is just 2 over here, right? And then I can use this, so it'd be the absolute value of the tan inverse of 3/2, right, minus the tan inverse of 2. And we can go ahead and check that we get the same answer from this one. And I'll go the absolute value, tan inverse of 3/2 minus the tan inverse of 2. And there we go. And we get the same exact answer, right? Theta is equal to 7.12. So this method right here, most likely you're going to use the dot product, but there are problems that you'll be forced to do these where you might not have all the information you need. So this is an alternate method that could come into play. And there you go. Thanks, guys.